They say that Archimedes once jumped out of his bathtub and ran naked through the street of Syracuse, shouting, "Eureka, I found it." He was excited because he understood how to determine the ratio of gold and silver in the king's crown. Like Archimedes, many of us have gotten stuck with a problem and felt the exhilaration of finally solving it. My research explains what makes getting insights possible. In particular, I concentrate on the contribution of geometric representations to mathematical problem solving. By geometric representations, I mean things like circles to represent sets and points on a line to represent numbers. The first step of my research is to determine whether geometric representation have a real impact on how mathematicians think about problems. So I carry out analysis of mathematicians that use these representations and mathematicians that reason without using these representations. This analysis had an interesting result. Mathematicians who use such representations have more insights. Building on this first result, I came up with an explanation of it, that we transfer problem-solving abilities from geometric objects in space to abstract and idealized geometric objects that are similar to the objects in space. So consider, for example, this blue square and this TV. The blue square can be seen as an idealized and abstract image of the TV. In this sense, it's similar to the TV. In this sense, geometric objects are similar to concrete objects. That's why when we think about problems geometrically, we're better at solving them. We deal competently with geometric objects because we deal competently with concrete objects in space, which are similar. Now I'm pushing my research forward. With colleagues in the psychology department, I will carry out experiments to test the hypothesis that we transfer problem-solving abilities from familiar objects to abstract and idealized images of these objects. To sum up, episodes of creativity like Archimedes often don't come out of a mysterious inspiration. They often are a comprehensible extension of ordinary problem-solving skills. This teaches us something not only about math and human creativity. These help us understand why, how, and under what conditions mathematical reasoning can be improved. And this can help us to provide advice for those teaching such reasoning to kids, for example. Thank you.